Alright, here we go. We're going to solve quadratics by factoring. This is section 13.4, so this comes directly after 13.3, day 3, the box method. So this would be, if you're trying to keep the order, what comes next. Today we're going to solve quadratics by factoring. The objective that we did in class is that students will learn to find the zeros, or the x-intercepts, or roots of a quadratic equation by factoring and pass a quiz with an 80% or higher. So there's a lot of these words in here that you maybe don't know or haven't heard of, and so we're going to go down here and work on some of the vocabulary. First thing is, let's remember what factoring is. That's like breaking down a quadratic into terms that can be multiplied together. If we do that with a number like 42, it would be 6 times 7 or 1 times 42, but we can also do that with quadratics. A new vocabulary word that we're going to learn today is called the zero product property. And it's actually not new. We've seen it before, but it's just a reminder. So let's talk about what that is. It states that if the product of two or more factors is equal to 0, then at least one factor must be equal to 0. Therefore, if I take a number a times a number b and it equals 0, then I know that either a is 0 or b is 0. And we've used this property many times before. If I have 5 times some number and it equals 0, then what does x have to be? X has to be 0 in order for that to work. So we've talked about this before and we've used it before. Now we're going to see how we can use it with polynomials. We want to find the value of x that will make the polynomial equation equal to 0. Let's try an example, then we'll graph the equation on our calculators to see what the zeros mean. So we're going to first use the zero product property to determine the solutions of this quadratic equation right here. First, we need to factor it. So when I do that, remember I take two factors of -5 that are going to add to give me -4. So if I just list them, the only two that I can use are 1 and 5. So if I'm trying to add them together to get -4, I'm going to make 1 positive and 5 negative. And if I multiply them and just quick check, that does give me -5. I did notice I messed up on one of my examples in the last video, so I apologize about that. Sometimes I go quickly and I factor things incorrectly, but this would be x plus 5, or x minus 5. Shoot, now I need white out. X minus 5, just trust me, that's a minus, x plus 1. So to solve this equation, in order for this factor times this factor to equal 0, one of these terms has to be 0. So let's look at this first one. When does x minus 5 equal 0? What value for x would x minus 5 equal 0? Well, if we can think about this one logically. Of course, x has to be 5 for it to be 5 minus 5 equals 0. But we can solve this just by solving for x, by adding 5 to both sides, and we get x equals 5. That's the value of x that makes this factor equal 0. But we have one more factor, so this one also could equal 0. So if I have x plus 1, what value of x makes this equation equal 0? So I'm just going to write x plus 1 equals 0 and solve for x, and I get x equals -1. So the values for x, where it equals 0, are 5 and -1. On a graph, that means it's a point. So x is equal to 0 at the point 5, 0, and -1, 0. We can always check our solution by substituting x back into the original equation. So let's do that on this side before we flip over. We have when x is 5 or x is -1. So let's go back to this original equation right here. Let's put in a 5, and we would have 5 squared minus 4 times 5 minus 5. And that gives me 25 minus 20 minus 5. And that does indeed equal 0. So when x is 5, then the equation is 0. Let's try 1. So if I put 1 into this equation, I'll come over here and I get 1 squared, or sorry, it's -1. So -1 squared minus 4 times -1 minus 5. And I get -1 squared, that's a positive 1. -4 times -1 is a positive 4. minus 5. We just go left to right. 1 plus 4 is 5, minus 5. That does equal 0. So I know that my 2 points worked. Now we're going to look at these on a graph. We haven't shown you how to graph these yet, but this is the graph of that equation that I just did. I want you to notice the connection between the graph and the work that we just did. We said that x equals 0 at 5, 0, and negative 1, 0. That makes sense on this graph because right here, y is 0 right here. So at 5, 0, and negative 1, 0. That's when y equals 0 right there. So we call these points the x-intercepts because the graph intercepts the x-axis at these 2 points. Here's my x-axis. Here's my y-axis. And we can also call them roots or zeros. Those are 2 other words that sometimes we use for these. We do x-intercepts, we write those as a point. A root or a zero, we write as like this, x equals 5, x equals negative 1. We wouldn't write those as a point. Describe the process of finding the zeros of a quadratic equation and what that means on the graph. So if you're watching these notes at home, just pause it, and I want you to try to write down what I just did. The reason why I have you do this is because we find where we have some gaps in our knowledge. When we have to actually write it down and explain it, we see the pieces that we don't understand. We can go back and look at those again. So I'm going to ask you to go ahead and do that. Pause the video and do that. Okay, now we're going to determine the roots of the following quadratic equations. So to find the roots, I first have to factor it. That's the first step. So I have to take 12. This is simple factoring because there's a 1 in front of the x right here. So I don't have to use box method. I don't have to use greatest common factor. It's not a difference of squares. So this makes this one pretty easy. So 12, I'm looking for factors that are going to add to negative 8. And if I just think 6 and 2, they're both going to have to be negative. And then when I multiply those together, I do get positive 12. So I'm going to use x minus 6 times x minus 2. Now if I set this equal to 0 to solve it, that means I'm trying to figure out when this graph intercepts the x-axis, when y is 0. So if I say x minus 6 equals 0 first, and I solve for x, I get x equals 6. And then I take my second term, when x minus 2 equals 0, and I solve for x by adding 2 to both sides, and x equals 2. So in these 2 places, x equals 6 and x equals 2, that's where that graph of that parabola is going to cross the x-axis. So somewhere about right here at 2 and right there at 6. That's where it will cross. Let's try number 2. Again, I can use simple factoring because I have a 1 in front of my x squared. And so I can't factor anything out, and I don't need to use the box method. I could use the box method, but it's not necessary. So 24. 2 numbers that multiply to give me negative 24 that I can add together to give me negative 5. So I'm a list of factors, and I can think that 3 and 8 are going to work. And if I'm trying to get negative 5, that means my biggest number needs to be negative, and my smaller number is positive. So I'm going to use x plus 3 times x minus 8, and I'm going to set that equal to 0, which means one of these 2 factors, either x plus 3 has to equal 0, or x minus 8 has to equal 0. So we need to find the values of x that make that true. So when does x plus 3 equal 0? Well, we're going to set it equal to 0 and solve for that. I can subtract 3 from both sides, so x equals 0 and negative 3. When x minus 8 equals 0, well, that's when x equals 8. So those would be my 2 roots. If I were to graph that once again, I would have one's negative, so let's say this is negative 3, and so here's my axes, and here would be positive 8. Those are the 2 places that that parabola is going to cross the x-axis. Number 3, simple factoring once again. I have a 1 in front of my x squared, so I'm going to take my negative 75, break it down, and I need to find 2 factors of negative 75 that will add to give me 10. So we got to think for just a minute Why don't we try taking 75 and divide it by 15? And that gives me, and I did just think that through right as I did it. I haven't done this yet, but 15 and 5. Those two numbers equal negative 75. Well, I have to make one of them negative. But I'm trying to get a positive 10 in the middle. So that's not really going to work because to get negative 75, oh yes, that will work. Excuse me. So I'm going to make 15 positive and 5 negative. And that will add together to give me positive 10 and multiply together to give me negative 75. So I have x plus 15 and x minus 5 equals 0. So can you see the pattern now? I hope I'm not skipping steps too quickly, but x would equal negative 15 and x would equal positive 5. I just need to change the signs here. Makes it a little bit easier. On those two problems, those are the answers. Okay, this last one. Now this one, I do have a 1 here, but this doesn't really follow the pattern of a normal quadratic equation because I don't have a c. So how would I factor this one? Well, this one I'm just going to factor out the greatest common factor. So I'm going to take an x out, and I'm left with x minus 11. Now can I still set this equal to 0 and solve? Well, if x is 0, or if this equation equals 0, then either this factor has to be 0 or this factor has to be 0. So if this factor has to be 0, that's easy. That's just x equals 0. If this factor has to be 0, what value of x makes this inside the parentheses 0? Well, it would be 11. But I could say x minus 11 equals 0 to figure out when it does. Add 11 to both sides, and x equals 11. So the two places here would be x equals 0 and x equals 11. What are the zeros of this equation right here? It's a little hard for me to show you my graphing calculator, but let's try this. Let's first think of 12 and break it down, and we have 1 and 12. Those are the two numbers that would make the most sense to get negative 11, because 3 and 4, I can't use that, 2 and 6. So to get negative 11, I would have to make this a negative 1 and this a positive 12, but when I multiply those together, that gives me a negative 12. So this one would be not factorable. But I do want to show you the graph of this. Let's see if I can get my calculator to show up. Okay. So if I go in, I didn't do this beforehand, so let's just try putting it in. X squared, so I go x squared, and we're going to work on putting this in your calculator. I know that you haven't done this yet. I just want you to watch this part. 11x minus 11x plus 12. Now I'm going to check my window just to make sure. Yeah, I think that'll work. So let's push graph here. What did I do wrong on this one? Did I put something in wrong here? Minus 11x. Okay, sorry, fix my window so you can see the parabola just a little bit better here. Now how come there's zeros here, but I couldn't find them by factoring? Well, sometimes we can't use the factoring method to find them, so we're going to show you guys in a couple of chapters how we'd solve something like this. But there are indeed zeros, and it looks like it's at 1 and maybe 12, but we can use this second trace button here and go to 0. And if I go left bound, don't worry, I'll be showing you how to do this soon. Right bound, and I look for a 0 here. There is one at 1.227. So it just wasn't one that was even. So factoring helps us find the even ones, but there are going to be some sometimes that are fractions or decimals, and I just wanted to show you that so that you're aware of that. That is going to be coming up. We're going to show you how to do that as well. So the answer to this is there are real roots. We just don't know how to find them sometimes on those unfactorable ones yet. That's coming up. Challenge question. Can you write the equation of the quadratic in standard form by looking at the graph below? What do we know about the zeros here? So if x equals negative 2 and x equals negative 3, what would that have to be in factored form? Well, that would have to be x plus 2 times x plus 3. Because if I set that equal to 0 and solve for x, then I would get x is negative 2 and x is negative 3. That's when they would have to be 0. If you plug negative 2 in here, negative 2 plus 2 is 0. If you plug negative 3 in here, negative 3 plus 3 is 0. So that would be when the equation was, that would be the factored form of the equation. Can I write it in standard form? That was the question. How would I write this in standard form? Oh, I just have to FOIL it. So I would have first x squared outside plus 3x inside plus 2x last plus 6. So I'd have x squared plus 6x plus, or 5x, excuse me, now I can't add, plus 6. That would be the equation of that parabola in standard form. All right, so practice now. I'm going to leave this part up to you to practice at home and come in and get the extra help if you need. I'll do maybe a couple. I'll do this first one and some of these that, well, we can do this one here. Let's try number 1. So I need two factors that add up to 81 that give me negative 9 in the middle. That multiply to positive 81 and give me negative 9. So that's going to be x minus 9 equals 0. Well, these two are the same exact factored form. So if x is 9 here or x is 9 here, either one's going to give me 0. So there's only one answer to this one. X is 9. And the graph of this one, just if you're curious, will come down. If 9 was right here, it's just going to come down, boop, just touch at 9 and go back up. Sorry, I know it's a little blurry. Let's see if we can get this to focus just a little bit here. Let's try number 3. If I factor out, I notice I have a 5x squared and a negative 45, so I'm going to factor out a 5x squared minus 25 equals 0. And we haven't gotten to difference of squares yet, but we're going to, but we can still solve it. Let's look at this factor, 5. Is there any way for 5 to equal 0? No, so we don't worry about that one. We need to look at this one in here. Can I make that equal 0? Can I make x squared minus 25? What is the value for x when that's 0? Well, I first have to add 25 to both sides. And I get x squared equals 25. And now I'm going to get rid of the x squared, I got to square root both sides. So x equals 5 is probably the answer that you thought of first. But let's think about this as well. If I square negative 5, does that also equal 25? It does, so I need to have plus or minus 5 on this one. All right, number 5. On this one, first I have this negative 2 over here, and I need it to be equal to 0, so I'm going to add 2 to both sides. Get myself a little extra room to work here. And I have 6x squared minus 14x plus 8. So on this one, the first thing I'm going to do, and this equals 0 right here, but I'm going to factor out a 2 because I see that they all have a greatest common factor of 2. So if I pull a 2 out front, I'm left with 3x squared minus 7x plus 4 equals 0. Now notice how I still have a number in front of my x squared, so this is going to alert me that I have to do the box method. But don't forget about this 2 out front. At the very end, I got to remember that it's still there. So if I do the box method, I take the first number times the last, and I get 3 times 4 is 12. And I need two factors of 12 that are going to add to negative 7. So that's going to be negative 3 and negative 4. So I would set up my box like this. First term always goes here, last term here, and then I have negative 3x, negative 4x. Now I factor up, and this is going to be a negative 1. Remember our rule about if we take out a negative, if the negative's right next to the number that we're factoring out, that's when I'm going to take out a negative. I hope that makes sense. On this one, I'm going to take out a 3x. I meant to put 4 here. I'm sorry. taking out a negative 4. You guys caught me. Okay, on this one I'm factoring out an x, so that's all they have in common. And this one, the only thing they have in common is a negative 1. So this would factor to, don't forget to have a 2 out front still, but 3x minus 4 and x minus 1. I'm still trying to solve this so it's equal to 0. 2 is a factor here, it is. But there's no x involved, so there's nothing for this value to ever make 2 be 0. So I'm just going to kind of skip over it when I'm solving. I need to look at my parentheses. So 3x minus 4, when does that equal 0? I'm going to solve that one first. I have to add 4 to both sides, and I get 3x equals 4. So then I need to divide by 3. X equals 4/3. Okay, let's try the next one. X minus 1, when does it equal 0? So x equals 0 at 1. There. So those would be my answers, 4/3 and 1. Okay, now try this objective quiz to see how you do. I want you to try to see if you can at least get 4 out of 5 correct. Remember on number 4, you first got to subtract 3x to the other side. And on this one, you have to add 12 to the other side before you can solve it. And try to figure out where the zeros are. Here's the answers to the objective quiz. 1 is x equals 2 and x equals negative 2. 2, x is 0 and a positive 3/4. 3, x is 6 and x is 2. 4, x is negative 1, x is 4, and 5 is unfactorable.